Alright guys, welcome to Math 0314, section 4.6, factoring trinomials. This section here, this is taught in a lot of different ways. I'm going to make this video based off of the way that I think is most effective. In subsequent videos, I will illustrate some other tools and other ways that you can do, you can factor trinomials. But I decided in this video I am going to just show you the way that I factor, which I think is the most effective and most intuitive way of factoring. Okay, if you've learned to factor in different ways, this is now being taught a lot of different ways in different schools. I don't care how you do it as long as you get the right answer, and I will show you other ways and why the other ways work, and again in future videos. Okay, all right. So let's start with what is factoring trinomials. Well, let's start off with this question, which is, what happens when you multiply x plus 2 plus times x plus 3? Well, this gives us, if we FOIL it, I'm going to FOIL it quickly, it's going to give us x squared plus 5x plus 6. By the way, if you're curious how I did that very quickly, if the coefficients are 1 and 1 for the x terms, what you can do is you can actually just add these, and this will get you the middle. It's obvious the first part is x times x, which is x squared, and 2 times 3, which is 6. So I know there's lines all over the place, but hopefully that makes sense. That you can only do that where you just add if the leading coefficients are 1 and 1. So, with that being said, what am I doing when I'm factoring trinomials? I'm taking this, and I'm taking it back here. And the way to go about doing this, so let's say I don't know what it's equal to, right? The way I go about doing this is essentially to do this process that we did where we said this times this times this, and then the sum of these in reverse. So what I'm doing is, I see I only have x squared, so I know it must be x times x. I look at the back and I see 6, and this is the part that's interesting. So you need to ask yourself, what times what is 6? So what I get to work, first thing that pops in my mind is 2 and 3. And I need it such that when you add or subtract 2 and 3, I get 5. And that is the case. That's it. And that's the answer. So that's a shortcut. That's the way that I do it. Notice here I chose 2 and 3 because that was the first thing, but I also knew from earlier that it had to be 2 and 3. But I could have chosen 1 and 6. And when that happens, I realize 1 plus 6 is not going to get me to 5, but 6 minus 1 is. So I could have tried 6 and 1. The problem with 6 and 1 is that the only way to get to 5 is by subtracting, right? But since these are both positive, right, it has to be that the end result has to be 6 times negative 1, which would have given me negative 6, but it needs to be 2 times 3, which is positive 6. In other words, you have to check to make sure at the very end it works. Hence, it has to be the first one. And this answer is no bueno. It's no good. Okay? So, how can this get more complicated? Well, that's the first question, right? So they actually start us off on something that's a little bit harder than what we just did, but that's okay, we can figure it out. And what makes this harder is that the leading term is 2x squared, but we can just simply say it's 2x and then x, because 2x times x is 2x squared. Then I hop to the back, and I look at 6, and I say, what times what is 6? Well, I'm going to piggyback off the idea here of 2 and 3. Now, here's where it gets interesting, because what I have to check that adds and subtracts to 6 is 2 and 3, 2 times 3, and 2 times 1. In other words, I have to see if I can get, I said 6, I mean 7, from 6 and 2. So you have to say 2 times 3 is 6, that's my first one, and 2 times 1 is 2, that's my second one. And can I add or subtract 6 and 2 and end up getting this plus 7? And clearly in this scenario, it's not true. Okay, so I'm going to draw a line through it. I'm going to rewrite 2x in x. And I'm actually just going to take 2 and 3, I'm going to flip it. I'm going to put 3 and 2. I'm going to play the same game. So now, when I multiply these together, I get 4x and 3x. And now I'm going to ask myself, I get 4 and 3, but these are x's as well, right? And I'm going to ask myself, can I add or subtract 4 and 3 and get to 7? And here it's true. They do add up. So that's the catch. Essentially, you're kind of reconstructing and then double checking foiling. Okay, let's do another one together because this can be a little tricky. So in this one, it's 13y minus 6 plus 8y squared. This one is trying to confuse you by putting these out of order, but we've seen this before, and all we have to do is rewrite it in order. What makes this one even harder than the last one is in the last one, the only way to get to 2 is prime, is 2 and 1. The problem here is the only way to get to 8, it can be, we could use 4 and 2, we could use 8 and 1. There's a lot of different values that work. Textbooks tend to use numbers that are closest together, so I'll start with 4 and 2. That's how I got 8. And then I'm going to go to the back side and do the same thing I did before and ask myself what times what is 6. They apparently like to use 6, which is 3 and 2. Alright? Then we check. We say, hey, 4 times 2 is 8. 3 times 2 is 6. With 8 and 6, can I get to 13? And the answer here is no. I can get to 14, but not 13. So there's no way it's going to work there. So I'm going to draw a line through it. Tried that one. I'm going to rewrite the same thing. Notice all I'm doing is flipping my back terms. So instead of 3 and 2, it's now 2 and 3. And we're going to check it again. This one is going to give me 12 and 4. So with 12y and 4y, can I get to 13? Clearly not. Draw a line through, and we're going to keep playing. So 3 times 2 is 6, right? But also 6 and 1 gives me 6. Alright, so I'm going to try 6 and 1 now. And so we're going to get 4 and 12 here. 4 and 12. And there's no way with 4 and 12 to get to 13, so we'll draw a line through it. And we'll try the next one. 4y, 2y. I'm just going to flip it 1 and 6. This is going to give me 24 and 2. And there's no way I can add or subtract these and get back. And this is the drawback to this method, is that it can take time to do, but I still recommend it. It's good. Let's try 8 and y, and then I'm going to stick with the 3 and the 2 because those are the initial ones. Notice, by the way, I went to 8 and 1 because 3 and 2 and 1 and 6 are the only factors of 6. It's the only way to get to 6. So I had to try 8 and. So this is going to give me 16 and 3. And with 16 and 3, aha! If I subtract 16 and 3, I get the 13. Now I got to be smart here and realize that it's a plus 13. So what I need is to get a positive 16, right? And a negative 3, because when I subtract these, I end up getting a positive 13y. And of course you could FOIL this out to see if it's true, but that is my answer. Okay. The other methods do try to make the idea of guessing and checking a little easier, but they're completely unintuitive. That's why I don't like them. This method takes some time sometimes, but that's okay. You just practice the method over and over and over again. So, let's move on. Okay, now this one looks really hard because the numbers are big. So what you want to do here first off is let's try to make the numbers smaller. So when I look at this, I can see that I can factor 80, 208, and 20. They're at minimum divisible by 2, right? Maybe 4. Actually, yes, 4. They're divisible by 4 because 20 divided by 4 is 5 and 8 divided by 4 is 2. So I know that 208 is divisible by 4, and obviously 20 divided by 4 is 5 here, and 80 divided by 4 is 20. So we can do that, but let's not also realize that they all have x's in them, so we can factor out an x as well. So we're going to take those out. So from the previous section, when we factor out like terms, that is still in place. So again, I said 20 divided by 4 is 5, 8 divided by 4 is 2. This is going to be 5y cubed. Now, from here, you are done. This is what's called prime. Okay? There's no work that can be done from here because these are not all the same. So we've gone as far as we can on number 3. So it's just illustrating that you can factor out like terms. Okay. So let's take a look at this one. So I think this is, well, let's do this one together, see what happens. So again, it's prime, so we're going to start with 2x and x. We see 14, that makes me think 7 and 2. Now, one thing here, as you work through these, you may wish to try different values and as you play with this, you start to try to think, maybe I should put 2 and 7 or something like that, right? My advice to you is do not overthink it. Just ask yourself what times what is 2, what times what is 14, try. And then try the next one. And flip the situation, try it again. And that procedure is better than trying to find the right combination initially. And the reason why I recommend that is that there's really a case of paralysis of analysis. There's sort of a situation where you look at it too much, you'll be thinking about it too much, and you'll be playing with numbers in your head, and you won't get the answer. It doesn't take long to do this. Once you get comfortable with it, it doesn't take a lot of time to do 2 times 7 is 14, and 2 times 1 is 2, and say, hey, does that add or subtract up to 9? No, right? And then just flip it again, and try again. Okay? So don't try to think through what it's going to be. This is one of the few times you'll hear a teacher say, don't think, just do. Right? And this gives me 4 and 7, and that's not going to work either. Right? So we exhausted all of our options with 7 and 2. So we're going to try 14 and 1. But you can see here that that's not going to work. You're going to get 2 and 14. And that's not going to give you 9. And then if I flip them, this is going to be 28 and 1. And that's not going to work, right? So the only way to get to 14 is 14 and 1 and 7 and 2. The only way to get to 2 is 2 and 1. We've exhausted all our options. None of them work. The answer must be prime. All right. So go ahead, pause the video now. See if you can do this one. Okay. So I'm assuming that you've given this a shot. This one shouldn't have been too bad because the only thing that multiplies to give me x squared is x and x. What multiplies to give me 16? I'm going to go with 8 and 2. 4 and 4 popped in my head, but 8 and 2 popped in first. And this is going to give me 2x. This is going to give me 8x. So with 8x and 2x, can I get to 10? If I make them both negative, it works. And negative times a negative is a positive. That works. So the answer is x minus 8, x minus 2. Bingo. Cool beans. Flipping on to the next one, go ahead, pause the video, give this one a shot on your own. I'm going to assume that you've done that. And here, again, we have a leading coefficient of 1, so this makes it just x and x. First thing that pops in my mind with 36 is 6 and 6. And we can see that we're going to get 6x and 6x, which if I add together gives me 12x. And this is actually a special situation. We can rewrite this as x plus 6 squared. What the book likes to do is piggyback, and they'll show you this as an illustration. They'll say that this is equal to this. And what they're going to say is, if you realize that if you square both your values, or you can take the square root of both of these, and when you take the square root of this and times by 2, you get this, which is this right here, then you can jump straight to this as the answer. Okay? Not too incredibly a fan of that. I think it's just as easy, doesn't cost any more effort to just break it down, and like we normally do. So I'll let you decide how you want to do that, but let's move on. Number 7. All right, so this one looks a little bit tougher, but I'm going to go ahead and start off with this as 2x, and this back, and 2x, sorry, and the back one I'm going to say 9y and 9y. This will give me 18. This is 18. So if I have 18xy and 18xy, that breaks down to 36xy. Okay, now this is negative, so they both have to be negative. Also, I skimmed over this, but the fact that 9y times 9y is 81y squared, don't let a term in the back scare you, right? In fact, if it really bothers you, if you have this sort of effect of y and then y squared, you can just take it away, do it without it, and then reinsert it at the end. Okay, but this just breaks down to 2x minus 9y quantity squared. All right, now what they're going to try to do is they're giving you quantity squared, and if that quantity squared bothers you, there's an easy math way around this. We just say we'll pick a letter, we use y, let y equal 2x minus 7, and every time I see these quantities, I'm just going to write y squared. So y squared minus 3y minus 40. And we'll factor this out, so we'll answer the question as to what times what is 40. The first thing, again, I'm not going to overthink it. The first thing that pops in my mind is 4 and 10. Okay? But that's not going to work because I'm going to get 10y and 4y, and there's no way to add or subtract 10 and 4 to get to 3. The other thing here to note is that I don't need to try, again, when they're switched in order. When the leading coefficients are 1 for both of the binomials, you don't need to check it flipped, because obviously you're just going to get 4 and 10 versus 10 and 4. So we'll cross a line through that. We'll try the next one. The next one that pops in my mind is 8 and 5. So we'll go ahead and put 8 and 5. Try again. And if I make this negative and this positive, I'm getting negative 8y and 5y, and that'll give me negative 3y. So there we have it. So this is y minus 8 times y plus 5, and we've broken it down. Now the important part here is to not forget, as I was working through this, I almost forgot about this. Y is 2x minus 7, so that is y minus 8 times y plus 5 is not the answer. We need to resubmit in 2x minus 7 for the y's. Okay, so I want you to note that the y now is 2x minus 7, the y now is 2x minus 7. Then we cleaned it up. So this breaks down to 2x minus 15. I'm using the parentheses to show that I substitute in that quantity, but because we're adding and subtracting, I do not need to, I can just drop them, so you don't really need to write them down if you don't want to. It's clear to just jump straight to it. And so negative 7, negative 8 gives me negative 15, negative 7 and 5 gives me negative 2. And this is my final answer. Okay, so be careful when you work through the problem. It's different than when you're watching me solve the problem. And sometimes we forget at the end that what we're solving for. So resubmit it back in, see what happens. All right. And the last bit is trying to scare you with y to the 4th and y squared. With this, again, we're just going to, we're going to resubmit in values. In other words, we're going to just plug in a value for y. But what I'm going to do is I'm first going to rewrite it as such. So actually what I'm going to do is I'm going to say let y squared equal to x. Now this is kind of a strange move here, but this is legit, right? Rewriting this as y squared squared, that is equivalent to y to the fourth. The reason we do this is that when I rewrite it and I get 6x squared minus 5x minus 4, that is a lot easier to work with. Okay, so we take this, we write it as 3x and 2x, because 3 times 2 is 6. With 4, I'm just going to say 2 and 2, because 2 times 2 is 4. I'm going to go distribute. I'm going to say that this is going to give me 6x and 4x. Note I want to get 5x. It's not happening here. Cross it out. And here, again, I can switch it, but since the numbers are 2 and 2, it doesn't matter. So we'll just go 3x and 2x. The only other way to get to 4 is 1 and 4. This is going to give me 12 and 2. And I'm not going to get, I want 5. So I'm going to keep going. We're going to take 3x and 2x. We're going to do 4 and 1. This is going to give me 3 and 8. Aha! Because if this is 3 and this is 8, if I make the 8 negative and the 3 positive, these are technically with x's, right? We will get negative 5. So I want the 8 to be negative and 3 to be positive. So this is 3x minus 4, 2x plus 1. Now, again, remember, x is y squared. So to finish this problem off, I need to, let me do this in a different color. To finish this off, we're going to replace x with y squared. And that's my answer. Okay. Now, also keep in mind when you're working through this that what you can do is, and this is sometimes what I do, is I just think of this as 6y squared minus 5y minus 4. And when I get my answer, and what was it this time? It was 3y minus 4, 2y plus 1. 3y minus 4, 2y plus 1, I think. Let me double check. 2y plus 1. Yeah. So I would write it like so, and then because I know it has to be to the fourth, you can just square these. So that's another way of treating it. Just think of it as a reduced version of itself, and then just resubmit it. Because it's clear that if these are y squareds, when you distribute, you're going to get y to the fourth, and then as you do the middle part, you're going to get y squared, and the backs stay the same. So that'll work. And that's the last part. This is a very important section. Please make sure that you are very comfortable with factoring. It does not go away. These factorings of trinomials is extremely important. So get comfortable with it, guys, and I will see you in the next video.